Hello and welcome to another learning opportunity together. If you are watching this any other time than the first time it was assigned, thank you for joining us, and would you please still set up your notes as shown on this screen. The topic is pH calculations. Record the date that you are taking notes, and the essential question, which is your learning target for today, is how do I calculate pH, pOH, H plus in square brackets, or OH minus in square brackets? Go ahead and pause the video if you need a little bit more time to set up your notes. Otherwise, let's get to it. So the first thing we want to make sure makes sense to you before we introduce the new topic today is what we already know about pH. So when you think of acids and bases, you think about there's particles inside the solution. And the particle that defines something as an acid is H+, or the hydronium ion. So we know that if there's more H+ particles, that means that it is by definition acidic. What it also means is that it has a lower pH, which we will talk about why that is, the math behind it in a little bit. And we know that there's a high H+ concentration. So a quick reminder that these square brackets are not just a symbol, they stand for molarity. So if we have these brackets around a number, that is referring to molarity. In this case, it's the molarity of the H+ concentration. So if there's a lot of H pluses, it's a low pH, and that is considered acidic. So if we decrease the amount of H pluses in our solutions, that means the OH minuses would have to increase because in neutral water, these two things are balanced. So if there's less of this, there would have to be more of the OH minus particles or the molarity of the OH minus concentration. And then that would result in a higher pH. So if H plus is low, then the pH is high. If H plus is high, then the pH is low. And again, we'll talk about the math behind that in a little bit. So then, by definition, if there is a higher than 7 pH, that would be considered a base instead of an acid. So that's a little review. So go ahead and process that so far. Pause the video, do a level 1 caustic question or a level 2 caustic question. Something that's kind of straightforward in your notes would be level 1. Something that requires a little bit of thinking, like a explain or a compare or a contrast, that would be a level 2. Go ahead, pause the video, come back when you're ready. All right, so then let's talk a little bit more about this pH concept. Rather than it just being something like maybe some of you have taken those little pH strips and dipped it in like a hot tub or a pool or even an aquarium, or sometimes people use them at work at like a cleaning solution. You dip those strips in there and it tells you the pH. What we want to talk about is what is the actual calculation behind it. So pH. So once upon a time, there was a guy named Soren Sorensen who decided it would be nice to mathematically describe the amount of H's and OH's in a solution, and he introduced this idea of the pH concept. And it's based on what we already know about water. So when Soren Sorensen was coming up with this, he already knew that water by definition is the molarity of your H pluses times the molarity of your OH minuses will equal 1.0 times 10 to the negative 14. So this is experimentally determined. So if you have the molarity of your two values for pure water, it will be 1.0 times 10 to the negative 14. So always pure water has this truth. Well, what you might know about logs is that logs really just focus on this power of 10. So the idea being that a p-value is a log value. So pH, or we're going to talk about pOH, tells us that it is a log value, and it's focusing on the power of 10. So if you want the pH of something, you would need to know the molarity of your H plus concentration, and you take the negative log of that molarity. Well, it turns out that there's also a pOH value when you have the molarity of OH minus concentrations. So still the same thing, negative log of the OH minus molarity. So that's how you get pH and pOH. But again, because the logs are both based on the power of 10, if you have a pH and a pOH from this and this, that should equal to 14 because it's negative log. So the p-value is negative log for both of them. So if you have your pH plus your pOH, that will equal 14. So now what we're going to talk about is that these three things are all related, or four things really: your H plus, your OH minus concentration, your pH, and your pOH. All four of those things are related. If you have one, you can find the other three. All right, process that for a few moments. When you're ready, go ahead and switch or pause the video if you need to, and then come on back. So how do we calculate these pH values? Instead of just knowing it's low or high or acidic or base, we can be specific. So to find the pH, so the log value of your concentration, it's the same calculation whether it's pH or pOH. You just have to make sure you have the right starting number. So literally you just tell your calculator negative, log, and then this will be a number in molarity. If it's pH, then you would have to know the H plus molarity. If it's pOH, then you would do the same thing, but you'd have to know the OH minus molarity. So just realize the orange goes together, the black goes together. If you wanted to find the opposite, you took one of those little test strips and you dipped it into a solution or a hot tub and you got the number. I know the pH. I want to know the molarity of this acid or base. Then what you need to do is basically tell your calculator to undo the log. Well, since logs focus on the power of 10, really what you're telling your calculator is you'll literally type in the number 10, negative of whatever the pH was, and then that will give you molarity. Or if you know the pOH, same thing, type in the number 10, negative of your whatever the value was given for pOH, and then that will give you OH minus molarity. Now, the only thing that can be a little bit tricky is that pH has to go with H plus and pOH has to go with OH minus. If you are given pH or you're given PO or OH, if they don't match, that's an extra step. So like it says here, if you have the pH but it's asking for OH minus, first you would have to go from pH to H, then you can go from pH to pOH, etc. I'm getting a little bit ahead of myself. The point is that they're all connected, but H and pH are the only things that match. pOH and OH minus are the only things that match. So pay attention to that. And then the last thing you have to be paying attention to are your sig figs. So in log values, the only part that matters are the decimal places. Everything in front of the decimal place you get for free. It doesn't make the answer more or less specific. It's just there to give you the right kind of integer. It's the decimal places. So sig figs for logs, you only look at the decimal places. The molarities, so the things in the square brackets, those are regular sig fig rules. And you'll see that in a couple examples. Would you take a moment and process these calculation processes a little bit? So a level 2 question or a level 3 kind of question. Level 3 could, imagine where you might have to calculate pH. That could be a thing. Or level 2 question could be compare and contrast the steps to find pH or to find molarity. Pause the video when you're ready and processed. Come on back for some examples. All right, so some examples related to this. So if you were asked for the pH, you know the concentration, it gives you a molarity, and you know that it's an H+. The first thing you check is that this is pH, this is H+, so they match. So really what I'm trying to do is I'm asking my calculator to give me the negative log of my H+ concentration. And it's just one H+, so it's just 0.020. You don't have to times this by 2 or anything. If it had been like H2SO4, we would have to take the molarity times 2 because there would be twice as many H's. But this is just one H+. Here's the molarity, so I literally just type this into my calculator. So I would type in negative, and then I would hit log, and then I would hit 0.020, and then enter. And then I get this number. So it's the negative log of the molarity of the H+ concentration, and I end up with this number. Looking at sig figs, the new rule is that it's only decimal places that count for sig figs. Well, this is a regular number. Placeholder, placeholder. I have 2 sig figs in my molarity, so I can keep 1, 2, look at the next number for rounding. The 8 rounds the 9 rounds the 6, but I keep 2 decimal places. 1.70 would be my science answer. So you are given the molarity, you're asked for the pH, which is the log value, so negative log of your molarity, and then our new sig figs. Pause that if you need a little bit more time to process. Otherwise, when you're ready, let's go on to the next example. So this one says, what is the pH of a solution that has a concentration of 2.5 times 10 to the negative third molarity in OH minus? So what you have to notice here is that you're given pH, you're asking for pH of a given OH minus. That isn't a one-step calculation because pH and OH minus don't go together in one step. So what you can find, because you have the OH minus molarity, is you can find the pOH because those go together. So you'll type it in like just the previous one we did, negative log the molarity is 2.5 times 10 to the negative 3. So it looks exactly like we did the last one. So hit the negative, then hit log, and then 2.5, and then the second E button, negative 3. So that's what this is. And then equals, here's my POH. And again, why was it POH? Because you were given OH minus, and those two things are related to each other. pH and OH minus are not directly related to each other. There's an extra step. All right, I see that this has 2 sig figs, so I look at my log value. 2 gets for free, so 6 and 0. I look at the next number for rounding. It does not round, so 2.60. So again, sig fig rules for logs, only the decimal places. So P values, that's how you know this is a log value. So these are my sig figs. Okay, but then I'm not done because the problem wasn't asking for POH, the problem was asking for pH. But remember, pH and POH are related to each other based on what we know about water. pH plus POH equals 14. So that means that I can take 14 minus my POH, and that will equal pH. So 14 minus the 2.60 for the POH that I just got, and that gives me 11.4. But sig fig rules, this was really a given, 14.0000. I'm subtracting, so I look at decimal places. This has 2 decimal places. This is just a definition, so I can keep 2 decimal places for my answer. So subtraction rules, remember, also look at decimal places. Now this makes more sense because OH minus by definition should be a base, and bases have high pHs, so 11.4 for pH makes sense. A pH of 2.6 doesn't make sense for OH minus because remember this was the POH, and then we used this calculation to get to the pH. Go ahead and again, pause for a moment if you need to, process that example. All right, and then let's do one more example together. Now I want to know the molarity of OH minus in milk if the pH is 6.60, just slightly acidic. So maybe the milk is not super fresh. This is why we say milk goes sour, because the older the milk is, the more acid concentration starts building up. But this one actually wants to know the OH minus concentration anyway. So for this problem, once again, what I notice is that this is pH and this is OH. It's not a one-step problem. But because I have pH, I can go directly to POH, and I can get that by subtracting. 14 minus the pH, which was given, is 7.4. But because I'm, again, using subtracting rules, this had 2 decimal places, this has unlimited, this is an exact definition, so I can keep my 2 decimal places for my POH. So again, notice what happened here. I'm trying to find OH minus molarity, which means I have to have a POH, but I started with a pH. So I do this calculation first. This gives me my POH value. And now what I can do is I can tell the calculator to undo this log, which will give me molarity. So when I undo the log, I take my 10, because log values are based on the power of 10, raised to the negative POH. So to type that in your calculator, literally just type the number 10 for 10, and then caret key, and then negative 7.4. So it'll look like this on your calculator, and then we get an answer pretty small, which we would expect. That's pretty normal for most molarities. They generally can be pretty small, especially because this is slightly acidic. So we would expect that the OH minus concentration would not be very high. All right, so now let's talk sig figs. My original value was a log value. It has 2 sig figs. This is a molarity, which is a regular number. So I look at the beginning of the number, 2 sig figs. I look at the next number for rounding. The 8 rounds the 9 to 10, which rounds the 3 to 4. And then I have to keep my 2 sig figs, so I don't just write 4. I write 4.0, but then don't forget that power of 10. E to the negative 8 means times 10 to the negative 8. And then one other little shortcut you can take is that your p-value and your exponent should be relatively close. If this had been a 1, then they should have been really close to the same, like 7 or 8. But that's another way to check. So the fact that this was 7.4 and this was 8 tells you that that's probably you did your math correctly. All right, so once again, go ahead and pause and process if needed. When you're ready, come on back. All right, so that brings us to the ends of our notes for today. So to finish your notes, finish doing 3 different Costa questions. You might have already done a 1 and a 2 or a 2 and a 3 or whatever. Do the one that's missing. Process, active learning, and then add a summary for the notes for today, which should go back and answer the EQ. So take a moment, active learning, finish processing, and thank you very much for joining in with our learning opportunity today. See you next time.